Well, let's try Magnesium Fluoride. And let's try Magnesium Sulfide. Take a minute, see if you can find the molecular formula of these for me. I'll go ahead and pause here. Alright, if you gave it a shot, let's think about it. So magnesium, in both cases, is Mg with a 2+. Now fluoride was F with a 1-, and sulfide was S with a 2-. Well, I have two positives, and I need two negatives to balance them. If I'm pairing them with fluoride, each fluoride only comes with one. So I'm going to need Mg2+, F-, and another F-, which is really MgF2. I need two fluorides to have enough negatives to balance the magnesium's positives. If I look at the sulfide, Mg2+, S2-, one of each is enough to balance the charges. So the formula is Mgs. And so we can take the name and we can identify the atom. We can figure out what column of the periodic table it's in and identify the charge we expect. Once we have the charges, we can then figure out, well, how many of each do I need to get a nice, neutrally charged compound or molecular formula. Additionally, we can take a formula and we can find a name for it. If I have CaO, well, Ca is the symbol for calcium. Calcium we'll find was in column 2, so we expect calciums to have 2 pluses. O is the symbol for oxygen. So oxygen, well, it's in the second column, and if it's paired with a calcium that's 2 plus, then we actually expect it to be oxide. We expect that it's probably the O2-. Because the idea is if I have a cation, I have to have an anion to balance the charge. So that cation out front, an element we expect to be positive, tells us the other parts probably have to be negative. And sure enough, if I do oxide, find its column, same as sulfur, it's a 2-. 2 plus, 2-, I'd only need one of each. And so the formula matches what I expect. The anion's name is oxide, so calcium oxide. And honestly, you don't need the capital, so just be calcium oxide. And so if you have a formula, you can make the name. If you have the name, you can make the formula. So let me give you a couple to try, and then you can pause it, and then coming back, we'll walk through them. So let's do Li3N. Let's do calcium phosphide. MgCl2. Sodium fluoride. Give those a try and come on back. Alright, if you gave it a try, if I've got the first one here, well, there are Li's, which are lithium. And you'll notice there's 3 of them. Each Li is a plus charge, so 1, 2, 3, and then I have a nitrogen over here. Well, if I have 3 pluses, I must have 3 minuses. If I look at the row of the, or column of the periodic table for nitrogen, we find that, yeah, nitrogen and phosphorus we expect to be 3 minus. So this is working, which means I have nitrogen that is a monoatomic anion. The O-gin goes away and becomes nitride. So Li3N is lithium nitride. Over here for calcium phosphide, calcium is a 2+. Phosp is phosphorus. The ide tells us it's an anion. Nitrogen and phosphorus are both -3s, so a phosphide is a P3-. Ooh, well these don't line up. If I have one calcium 2+, and a phosphide 3-, I don't have enough positives, so I could add a second calcium. That gives me 4 positives, which means I'd need another phosphide. Well, they come as 3-. So now I have 6 minuses and 4 positives, so I add more calcium. And there we go. If there are 3 calciums, I have a total of 6 positives. 2 phosphides gives me 6 negatives. That will cancel out. So my formula is Ca3P2. I need 3 calciums and 2 phosphides as the ratio before they cancel each other. Jumping down to MgCl, well, expect magnesium to be 2+. I expect Cl to be a minus. I need 2 of them to balance it. So the formula looks good. Name is just magnesium chloride. We don't mention that there's 2 chlorides. We just call it magnesium chloride. We just name the 2 ions. Knowing how many is dependent on the charges, and we are left to do that math if we wanted to know. Over here I have sodium and I have fluoride. So there's an Na+, there's an F-. I'll need 1 of each. So NaF is the formula. Alright, so that is the general idea of how we name ionic compounds. We have to identify the charges on the ions based on the periodic table, and we have to put them in order of the cation first, anion second.